Materials for bridges, buildings, and other infrastructure. Energy. High durability super strong materials can also be used in the energy industry to produce materials that can withstand the harsh environments of oil and gas exploration and production. This can include materials for drilling equipment, pipelines, and other critical components. Moreover, the use of high-durability super-strong materials can also have significant environmental benefits by reducing the need for frequent repairs and replacements of materials, and by reducing the amount of waste generated by the manufacturing process. This can contribute to a more sustainable and environmentally friendly future. To fully realize the potential of high-durability super-strong materials manufacturing technology, it is important to continue investing in research and development, and to promote responsible and sustainable practices throughout the life cycle of the materials and associated industries. This can involve the development of policies and regulations that ensure responsible and sustainable practices, and that promote equitable access and distribution of benefits and risks associated with this technology. While high-durability super-strong materials manufacturing technology presents many potential benefits and applications, there are also several challenges and considerations that must be addressed to fully realize its potential. Here are some of the challenges and considerations associated with this technology. Cost. The cost of manufacturing high-durability super-strong materials can be higher than that of conventional materials. This can limit the accessibility of this technology to certain industries and applications. Availability of raw materials. The availability of raw materials such as carbon nanotubes and graphene can be limited, which can impact the scalability and commercialization of this technology. Technical challenges. The manufacturing process of high-durability super-strong materials can present technical challenges such as the need for specialized equipment and expertise. Moreover, the manufacturing process can also be energy-intensive, which can impact the environmental sustainability of this technology. Safety considerations. The use of high-durability super-strong materials in applications such as aerospace and defense can raise safety considerations, such as the potential for materials to become brittle and fail in extreme conditions. Environmental impact. The manufacturing process of high-durability super-strong materials can have an impact on the environment, such as the release of pollutants and greenhouse gases. It is important to ensure that the environmental impact of this technology is minimized and mitigated. To address these challenges and considerations, it is important to invest in research and development, and to promote collaboration and interdisciplinary approaches. This can involve developing new materials and manufacturing processes that are more sustainable and cost-effective, as well as promoting responsible and sustainable practices throughout the life cycle of the materials and associated industries. Moreover, it is important to engage with stakeholders and involve them in decision-making processes related to the development and deployment of high-durability super-strong materials. Manufacturing technology. This can involve developing policies and regulations that ensure responsible and sustainable practices, and that promote equitable access and distribution of benefits and risks associated with this technology. High-durability super-strong materials manufacturing technology has the potential to revolutionize various industries and sectors by providing materials with exceptional strength and durability. Here are some examples of the potential impact of this technology on various industries.